You can't answer a question like this without knowing how to write electronic configuration and structure of atom. So here is a question on chemical bonding, and we have different types of bonding, where we have electrovalence bonding, also called ionic bond. We have covalent bond, which are divided into two, which is dative bond or coordinate covalence and ordinary covalence. The coordinate covalence is also a dative bond, and we have the ordinary covalence. We have the metallic bonding, we have the hydrogen bonding, we have the van der Waals weak force of attraction. Now, before you know this, you must also understand the definition of bonding. The two most important bonding here is covalence bonding and electrovalence bonding. Now, in electrovalence bonding, it involves transfer of electrons from one atom to another, usually from the metals to the non-metals. While covalent bonding involves sharing of electrons between two atoms. Now, in ordinary covalent bonding, the atoms they share are being brought in, the electrons they share is being brought in by the two participating atoms. But in coordinate covalent bonding, called dative bond, the electron they share is brought in by one of the participating atom. So that is what differs the coordinate from the what ordinary covalent. Now, let's draw the structures of the atoms. We have sodium, two sodium atoms and one oxygen atom. Now, sodium Na, which has 11 electrons. The electrons are configured in this manner: 2, 8, 1. Oxygen, which has 8 electrons, the electrons are configured is in this manner: 2, 6. Now let's draw the sodium atom. Now we have the first shell carrying 2 electrons. We have the second shell carrying 8 electrons. And we have the last shell carrying 1 electron. Here we have 2 sodium atoms. So we repeat this structure by saying the inner shell carrying 2 electrons, the middle shell carrying 8 electrons, and the outer shell carrying 1 electron. So these are our 2 sodium atoms. Then the oxygen, which has 8 electrons, and the electrons are configured in this way, has 2 shells, where the first shell is carrying 2 electrons, and the outer shell is carrying 6 electrons. So here are the 8. 1, 2, 3, 4, 5, 6, 7, 8. And these are the 11 for the sodium. Now, let's see what will happen here. This sodium is trying to attain octet stability, which refers to a type of stability that has 8 outermost shell electrons. It wants to have 8 electrons in its outer shell. This oxygen has 6 in its outer shell and also wants to have 8. So what do you think will happen? Now, sodium cannot get 7. Therefore, it will be easier for it to lose 1. And it will lose 1 to oxygen. And the oxygen will receive that 1 here. And this sodium will also lose 1 to oxygen, which will position here. Now, having done that, this sodium have lost this last shell electron. It has lost this valence electron, and therefore becomes sodium ion. And this oxygen, having gained 2 electrons from each of the participating sodium, becomes oxygen ion. Gain of electron carries a negative charge. Loss of electron carries a positive charge. The 2 sodium lost one electron each, while the 1 oxygen gained 2 electrons. That is why it's carrying 2 minus. Now, what kind of bond can you see here? You can see transfer of electron from one atom to another. And this type of bonding is known as electrovalent bonding or ionic bonding. We call it ionic bonding because it involves the product formation of ions. As you can see, we now have sodium ion and oxygen ion. So that is how to answer a question like this. You must understand how to write electronic configuration and how these electrons are being configured in an atom in order to successfully answer this question. Thank you very much and do have a nice day.